Now let's take a tour of the menu that you can find. A version of Scratch, a Python game to play, a version of Minecraft that you can program. So congrats! Project complete! Thank you for following and for completing the steps that I have mentioned. Now for the Nano, for the code editor to be used, Nano is one of the best text editor in command line environment inside Linux systems. We will use it as our default coding program. Now it's really simple to run it. It's just to write your Nano, your file name, and it will open a new file with the name you assigned in the previous command. For example number 1, we have the blinking LED. Goal from example is that running an LED and make it turn on and off indefinitely. Now this would require these following components. You need the breadboard, Raspberry Pi board, an LED, a 300 ohm resistor, and connection wires. For preparing project parts, now this is just the same as I've mentioned earlier. You would need to be running an LED and making it turn on and off indefinitely. So for the example 1, we have the blinking LED. We have here this coding here for our Raspberry Pi. So applying the code and see the result. To close a program, click Ctrl+C to run the code right. If you try to run it again using the same sentence, you will get warning and tell you that the output you are trying to use is already used. And this message would appear when running a software after another at the very same port. You can ignore this message, and if you would like to hide it, use this sentence. Type gpio.setWarnings, open and close parentheses, false. Now this again will hide this sentence. Now this is used to call libraries. This is always the start of each program, calling time library for time measurements and calling the GPIO library. Now setting the pin function as input or output here. Now while is used to repeat the commands indefinitely for a defined number of times, used to turn the output on and off depending on the numbers inside the practices. First number is the pin number, while the second is the state on or off. Now note that you can use true or false instead of on and off. To control the amount of time used for the previous line to be executed or viewed by the user, now you would need to wait for 1 second. So we will develop the code so that it will show a line after turning the LED on and off. Now this is the result on the Nano editor screen. Reading the input values from a switch. Now the goal from example is reading a digital input values using a switch and display results on the screen. Now it will require again a breadboard, Raspberry Pi board, switch, 10K ohm resistors, connection wires. And example number 2 is reading input values from a switch. So explaining the if statement. Here we have this coding here for the if statement. Again, this is explaining the if statement. Now for the example number 3, in running the LED using the LDR, the goal here is running an LED and make it turn on and off using the light emitting diode. Here, you would need a breadboard, Raspberry Pi board, an LED, and a 10K ohm resistor, a 300 ohm resistor, and an LDR light emitting diode, and connection wires. Now save the file and then run the code, the sudo python light sensor.py, then close the light room or place your hand at the LDR and see what will happen to the LED. So first you can change true to false and see the result. 2 is that you can add print sentence when executing the 2 output commands. So here is an example on running the LED using the LDR. For the example number 4, we have the PIR motion detector. The PIR is one of the most important sensors in practical life. It is actually used in many projects such as protection and smart doors. You can see it mostly in centers and company doors, which opens once you get close to it. Now, this type of sensors can use different methods to detect ultrasonic waves, infrared signals, and many more. And in this lesson, we will use the IR-based PIR motion detector. So again, this sensor can sense the presence of an object at a distance of 7 to 10 meters and an angle between 90 to 110 degrees. And this is enough for a small room. This sensor has 3 connection points, which are volt in 3 to 5 volt red wire, digital out yellow wire, and ground black wire. And then we will connect the red wire to the pin 1 in the PI, which is the 5 volt output. And then connect the yellow wire to the 23 pin and connect the black wire to pin number 6, which is the ground. So start the editor by typing on the nanomotion.py and following the rest of the code. Then run the code and see the result. The detector gives 3 volt output signal whenever a motion is detected. And to improve the code, we will add 300 ohm resistor and an LED and edit the code as the following. The BCM numbering instead of numbering by order. Now there are 2 famous numbering systems for port numbering. We have board numbering and we have BCM numbering. Most people prefer to use BCM numbering instead of board numbering because Adafruit breakout cable, just like the image you have seen, note that the BCM numbering is the one inside the boxes at the both sides, while the board numbering is on the side of the circles. Here. Now here you can appreciate the BCM numbering instead of numbering by order. Now where is the difference? The only difference is in the calling method of the GPIO library in Python. If we want to run the terminals in the GPIO order, we will call the library using gpio.setMode, open and close parenthesis, gpio.board, all caps. If we want to run the port using BCM numbering, we must call the library using this line, gpio.setMode, open and close parenthesis, gpio.bcm. Now note that this is important thing to do because you will find lots of projects online using BCM numbering, so you need to take a good care of this and connect all components to pin the right way. For the Adafruit protection box and connection cable, the Adafruit is considered as one of the biggest open source electronic companies that have many products for Arduino, Raspberry Pi, and much more. This company provides protection, box, and cable that are necessary before starting to use the Raspberry Pi. Note that the cable uses BCM numbering, so be sure to import the BCM library in Python.